Hello, programming languages students. Welcome to the first true C video where we get to see C code. We had a little warm-up video with Java where we noticed that Java does some interesting things with how it works with memory, and it doesn't really provide you control to control what happens with memory or how memory is used, or it just does its thing and you work with it. So C gives you more control and more power. That means that you can work with memory a lot more closely, control how methods work, control exactly how memory functions, um, which has a lot of benefits because you have more control, but also some costs in that you have to write you have to write code a little differently, you have to be a little more careful with how you write things, and you can potentially do some dangerous things if you're not careful. So to start with, when we're working with C, um, there are a lot of advantages to having a real compiler, a physical downloaded compiler. But since we're only in C for a week, an online compiler will do, help avoid all the setup problems. So I'm using Online GDB. There's a link to this in the slides. There's even a couple more IDEs that I've linked to and used in the past. I'm not sold on any particular IDE. I'm not advocating for this one. I kind of like it because I can get rid of ads pretty easily. It compiles and runs a little bit more slowly than others, but it consistently does compile and run. But there are other IDEs and other benefits to them. This is just what I'm going to use for these videos. So whatever IDE you use is fine, as long as you can turn in the C file, download it and submit it. So let's dive into C. Let's actually get to the nitty gritty here. First thing you'll notice, I'm including two libraries, standard IO, standard lib. These include statements are a little different than Java, but it's the same idea. Mostly for now, you'll just copy these. It's just including libraries. There's a method header up here. I'll jump back to this in a minute. But first, I want to talk about some interesting similarities between Java and C. So first of all, loops are at the core of both languages, right? And, well, loops should look pretty darn familiar. The same thing, right? Variable declarations, very familiar. Same thing. And so the basics are really similar between the two. Now, the first difference you'll run into, the first thing that you're going to have to be wary of and aware of is printing. There is no system.out.println, and there are a couple differences in rules. Um, C generally doesn't allow you to add things together in a print statement with plus. I can't add an integer and a string. Heck, a lot of times you can't even just print an integer easily. And so very, very commonly in C, we see printf used. This is formatted printing. This exists in Java as well, but in C, this is the option. This is what you use. And so the way this works is you create a string that you're going to print and it has symbols inside. %d means a decimal number or a base 10 number, which is our normal base for math. And so when you have a %d or a %p for a pointer or a %f for a floating point number, um, this symbol is basically replaced with the very first variable you have after a comma after this sentence ends. So in other words, I replace this %d with an I. If I wanted to print two numbers, I could do %d, comma I, and now I'd print I twice. So this is basically just a series of rules that allows you to format printing. You do need to supply your own new lines. \n moves you to a new line. So there's no print or println. It's just printf with either a \n at the end or not. \n means go to a new line. So you control the formatting, you print things out. This print statement shouldn't take too much to adjust to, even if you haven't really used it in Java. Some examples in the slides should help. If you have used it in Java, then you already know what you're doing. So we'll move on from prints. Again, the slides have good references for this as well. So the next thing is methods. You can create methods in C, but C is an imperative language. It literally goes top to bottom. And so the one key difference here, we have a test method that takes an integer. I'm going to scroll to the bottom here. At the bottom, I've defined my test method, void test method int I, and it prints. So it just prints the value I pass in. So our void test method int I, we declare it down here. This looks very much like Java. We don't have public. C is not object oriented. Public and private don't really mean anything here. I don't even believe you can write them. So you just do return type, method name, inputs. The key difference is that in C, since you read top to bottom, at the very top of your code, you need to have the method header defined. So it knows that this method exists when it runs the rest of this code, and then when it needs to call the method, it goes down to the bottom and finds it. This is a convention. This is not required. You could define and implement the method up above main, but this is a convention that I personally prefer, and it's also pretty preferred in C. And so basically what you want to do is put your method header up here with a semicolon, and at the bottom, define your method. So let's run our code and let's look at the printouts that we have so far. I'm going to run it real quick. With this IDE, it prints out at the bottom. I've kind of scrolled it down so that we could see the code a little more. But to review, we've looped through and printed I equals 0 to I less than 5, 0, 1, 2, 3, 4. We then we use test method with 3, so we pass 3 in and print it. So that's all of our printouts so far. Loop 0 through 4, print 3. All right, so Booleans. Booleans in C, there is a library called stdbool.h, which allows you to create Booleans. These are the true false values, but C can function without it, and generally most people function without it in C, although people like it, people use it. It's certainly fine if you want to use it. But in general, C works using integers as Booleans. And so let's see here. We have int I equals 0 if I, so literally if an integer, print I equals 0 is true. Set I equal to 1, print I equals 1 was true. Set I equal to -1 if I, print I equals -1 was true. So these are 3 print statements, and what I wanted to demonstrate here, if you look at our printouts at the bottom, we get I equals 1 was true and I equals -1 was true, and notably, not I equals 0 is true. So the way Booleans work in C, or the way conditionals work by default, is that it works on integers. For any non-zero value, could be positive, could be negative, could be a million, could be 1, could be -1, could be -10 million. Doesn't matter. Any non-zero number is true, any 0 is false. And that's it. So if you want to do conditionals, you can just pass in an integer. Usually people use 1 as true and 0 is false, but really any non-zero is true, 0 is false. So non-zero true, 0 false. All right, moving on. The biggest difference is arrays. So I'm going to spend a little time talking about this. You can create arrays similarly to Java. Note that in Java, you would do char array A equals new char array with 3 elements, and that's it. In C, that is not how we do this, because in Java, an array is actually an object, and so we have to create a new object and point to it. In C, arrays are not objects. They're actually a thing called pointers that I'll talk about later. But the key here is that these are not objects, and so there will be a couple problems we run into, and this will create a 3-element array. So char A is a 3-element array. So A is a 3-element array of characters. And so if we just print it initially, you may not actually know this, but in Java, when you create an array, it initializes everything to 0 or a default value. In C, as a warning, it does not. It just gives you whatever values happen to be in memory, wherever it creates. So when you create an array, you have to create memory to store all the values. In C, it points you to the memory, and then whatever happens to be there from whatever code ran previously or whatever happened to be there in memory from the computer before, it stays there. In Java, it points you to memory and then it clears it all out. So that's one key difference that may or may not show up for you, but it's a notable difference. In my first printout down here for arrays, you'll see that my commas show up and my spaces show up, but then nothing else shows up. Now, as it turns out, this behavior, I kind of got lucky that it was just empty and blank. It could very well print letters, it could very well print random numbers, it could very well print anything. It's unpredictable. So this very first printout would be unpredictable. However, I can set values, just like I would in Java. A index 0 is A at index 1 is B, A at index 2 is C. And then if I print it out, we print out ABC. And it's also worth noting that since C is not object oriented and doesn't really have doesn't have objects, there is no string object. And so this character array is considered a string. So %s prints a string, and you can print a character array, and it will print out ABC. So an array of characters is a string in C. Now, where's the biggest problem with this? With arrays not being objects, with arrays just being and no string object, no array object? Well, you can't write for loops like this, right? In Java, you would try, if you wanted to loop through an array or a string, you do int I equals 0, I less than a dot length, I plus plus. Can't do it in C. There is no length, right? Length is either an instance variable or a method that tells you the length of your array. There's no methods or instance variables. There's nothing that stores this. So what's the convention? How do we know how long an array is? How do I loop through an array? If I can't do b dot length, what do I do? Or a dot length, what do I do? Well, let's do another little demo here. Let's say I create a character array b, and I initialize it like I might in Java. Now, no matter how you set it up, it doesn't matter. The rules I'm about to talk about apply regardless of how you create the character array. But I create this character array and I initialize it to 0, 1, 2, 3, and then I print it. So we get 0, 1, 2, 3 down here at the bottom. So I've printed those characters. Well, how do we find the length? Well, without a length variable, before we go into our loop, we don't know how long a string is. There's no variable that stores this information. And so we use a while loop instead of a for loop. Note we do I equals 0 and I plus plus, but the condition we check is if b at index I does not equal \0. So this \0 is important. This is called a null character. Its integer value is literally 0. And basically what happens in C is when you create an array, regardless of how you create it, you actually take one more piece of memory than you ask for. So there's an implicit addition to any array you create of one more piece of memory, and that piece of memory stores \0. That's the convention in C. And when you create an array, that's what happens here. So we have, when we create this character array B, it stores 0, 1, 2, 3, and then implicitly, without writing it out, without writing anything else like this out, it adds one more piece of memory, which is a \0 or a null character. So if you were to, by the way, add your own null character, you would still reserve one additional piece of memory with a null character. So when you're creating an array using either this kind of declaration, char a3, or this kind of initialization, char b equals this, an extra piece of memory is added that adds a null character. Now, we're going to revisit this later because it's important, but the idea is you loop through your array until you hit the null character, and that's when you're done. That is the length of your string, is when you hit the null character, your array, your character array, your string is done. And so you'll see here I print the value of I and the character value stored in our array. So 0, 0, 1, 1, 2, 2, 3, 3, and then we stop because we hit our null character. And so the very last thing I wanted to highlight is that because these are not objects, if you try to access something in C, an array in C, beyond its length, you get an error. Sorry, in Java. In Java, if you go beyond the length of an array, you get an error. In C, if you go beyond the length of an array, it's fine. There's no stored limit to what the length of the array is. And so this is kind of scary because it allows you to access, edit, manipulate, do things with memory that you really shouldn't have access to. And so this is a really interesting problem with C. If you want to dive into it, I have some extra reading, but it's led to hacking, buffer overflow issues. This caused a lot of problems at various points for security. And so there's some readings in there if you want to look at it, but that's it. That's the main differences here. So hopefully that's a good intro to C for you.